Have you ever wished you could just tell your phone what to do in an app and have an AI just take care of it? I don't mean just opening the app, but actually navigating it, tapping all the right buttons, and completing a whole task for you. Well, today we're going to break down exactly how that tech works and even how you could build it yourself. But that brings up a huge question, right? How on earth can you build one single AI agent that can figure out and operate the millions of different apps out there? I mean, they all have their own unique design. It seems kind of impossible, but that's the puzzle we're going to solve together in this explainer. Okay, so let's dive right into this. We're going to start by looking at one of the first major attempts to crack this code. It's a project from Tencent called App Agent, and their approach, well, it was radical and honestly, very human. App Agent was built on a really simple idea. What if the AI could just see the app screen, the same way you and I do? So instead of trying to get bogged down in complicated code, it would just look at the pixels on the screen and decide what to tap based on sight alone. So here's how it actually works, step by step. First, a script that's running on a connected computer takes a quick screenshot of your phone. Then, and this is the clever part, because AIs are surprisingly bad at guessing exact pixel locations, it draws these little numbered boxes on top of everything that looks like a button. It then sends that marked up picture to a powerful vision AI and basically asks, hey, to get this task done, which number should I click? The AI just replies with a number, and the script taps those screen coordinates. It's literally like having a robot looking over your shoulder and tapping for you. Now, the truly mind-bending part of App Agent was something they called its exploration phase. Before you even give it a task, it can just poke around an app on its own, see what happens, and basically write its own user manual. It learns by playing around. But, and it's a big but, there's a huge catch. Sending these massive, high-res images to an AI for every single tap is incredibly slow and very, very expensive. It was an absolutely brilliant proof of concept for sure, but just not a practical solution for everyday use. So, you see, the vision-first approach was a fantastic start, but its flaws really paved the way for a much smarter, much faster solution. And that brings us to our next project, a little something called Droid Run. The team behind Droid Run asked a totally different question. They said, why look at a picture of the house when you can just read the blueprint? So instead of analyzing pixels, Droid Run dives deep, right into the app's underlying code to figure out what's on the screen. The process here is a complete 180. It ignores screenshots altogether. Instead, it extracts something called the accessibility tree, which is really just the raw code that tells the phone's operating system where every single button and text field is. It then converts that entire screen layout into a clean, simple text file. An LLM reads this text, which is incredibly fast and cheap to process, and instead of guessing a screen location, it identifies the button's unique code ID. The script then tells the phone to tap that exact ID. No guesswork involved. And what was the result of this huge shift in strategy? Well, by skipping that whole slow, expensive process of analyzing images, this text-based method turned out to be roughly 3 times faster than vision-based agents like App Agent. 3 times! That's a game changer. I mean, the advantages are just crystal clear. It's faster, it's way cheaper because text is just so much smaller than an image, and it's far more reliable. But maybe best of all, think about this. If a developer updates their app and, say, changes the color of a button, a vision agent might get totally confused. Droid Run, it doesn't care. As long as that underlying code ID stays the same, it's going to work perfectly every time. All right, so App Agent and Droid Run were amazing research projects, but let's be real. They were developer frameworks. You had to run scripts from a computer that was plugged into your phone. The next big leap was to take all this power and package it into something anyone could just download from an app store. And this is where a company called ZeroTap comes into the picture. Now, to really get what ZeroTap does, you need to know about one crucial piece of Android technology, the accessibility service. This is a super powerful feature that's built right into the operating system. And with your permission, it lets one app read the screen content of other apps and even perform taps for you. It's basically the master key that unlocks all of this on-device automation. And that's the magic of ZeroTap. It's not some script you have to run from a laptop. It's a native, standalone app you can just install from the App Store. It uses that accessibility service to see what you're doing and to act on your behalf, all self-contained right there on your phone. Think of it this way. App Agent and Droid Run are kind of like engine prototypes that engineers test out on a workbench. ZeroTap, that's the finished car you can actually get in and drive.
It's built for real users, and it can even integrate with other automation tools on your phone, making the AI just one part of a much larger workflow.
So what happens when we put all these pieces together, right? We've seen this evolution from a slow, vision-based experiment to a fast, text-based framework, and finally to a consumer-ready native app. By combining the best ideas from this whole journey, we now have a really clear blueprint for building a truly powerful mobile agent.
So here it is, the modern playbook. Step 1, build a native Android app that acts as the hands, and it gets its power by using the accessibility service to see and tap. Step 2, don't use screenshots. Use that same service to pull the UI as clean text, just like DroidRun did. And finally, step 3, use a powerful LLM like Gemini as the brain. You send it the text from the screen along with your command, and because these models are fantastic at reading code, it'll quickly send back the exact ID of the button your app needs to press.
So there you have it. We've gone from a theoretical possibility to a practical 3-step plan. The technology is here, and it's faster and more affordable than ever, and the path forward is clear. It's really no longer a question of if this is feasible. The question now is, what are you going to do with it? The playbook is in your hands. What will you build first?